PhD scholar at Department of Mathematics and Statistics, IIT Kanpur. I am a PMRF fellow. Before that, I was a CHR fellow, and I have cleared my CHR net with 108 rank. Okay. So from the last class, we were discussing about the conic section. So conic section is nothing but a section of intention of a plane with some cone. So here you can see in the last class we have discussed about conic sections, different figures we are obtaining to the intersection of the cone with the plane. So first we have discussed about where we will get a circle. After that we have went to the case where we get ellipse, and after that we went to the case where we get a parabola. And then we have discussed hyperbola case with some degenerate cases we have discussed in the last class. Okay, so in today we will start our session about a detailed study of this circle, which is one of the conic sections. Conic section are nothing but the curves obtained by intersection of a right circular cone by a plane, and we obtained a circle. And here you can see that how we have obtained this circle. So today, our topic and our starting point, our discussion will be the circle. So today we will discuss these things a little bit deep. So by circle, one knows a round shape like this, a geometrical figure which is round, and there will be a center. And from this center O, if I call it O, then the distance from the center to any point on this path will be equal. Like if you stand here, 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 or here, anywhere you stand, the distance from you to the point O will be always same. Then the geometrical figure is called a circle. Okay. So by definition, what is the definition? A circle is the set of points in a plane that are equidistant on a fixed point in the plane. Okay. So whatever I have told that we have a fixed point and set up all those points which are equidistant from that fixed point. So the fixed point is noted by the point O, and here it is the point. And the black lines, the colored black line denotes the set of all those points which are equidistant from the point O. Okay. So this O is called the center of the circle. This O is called center of the circle. Center of circle. And the green lines, but denoting the distance from any point of the line on the uh, set denoted by the black line from the origin is denoted by the distance. The distance is called the radius. R is called radius of the circle. Okay. Now, our next motive is how can I write this geometrical figure? This is our interpretation, right? How we can, what is the circle and how we denote a circle geometry. Now, the question is how we can represent this geometrical figure in context of mathematics. So, for that, let us assume that the origin has some origin on the plane, so it has some location. So, let us assume, let The origin is denoted by h comma k, and this is the coordinate of this point O. Okay, and x comma y denotes an element of that set. Denotes an arbitrary element from the set which is equidistance or of distance r. Equidistance not set of distance of which are set of all denoted an every element of the set, which is is at a distance r. Okay, the r is fixed and it is denoting the radius of the center, which is the fixed value, with denoting the distance from the origin any arbitrary point on the black card. Fine. So in that case, how we can write this? So xy is an arbitrary point. So from the arbitrary point, if I find the distance from the arbitrary point xy from this fixed point hk, then the distance will be like um, distance will be of the from this x minus h whole square y minus k whole square. Correct? And what is the distance? I know the distance. I have represented the distance with from this point and from up to xy like this. But what is the exact measurement of this distance? That will be r. Why r? Because that is the distance that's how that is what we have represented, right? And so we have considered that the elements which are xy are the all those elements which have distance r from the point h. So obviously this equation will be true, right? Then this implies x minus 8 whole square plus y minus k whole square is equal to r square. And note that here r comma h comma k are fixed real numbers and must be r should be positive. And if r is greater than equal to 0. If it is equal to 0, then it will only denote the point. Nothing but that. That will like I will come later. So understand that this r should be greater than equal to 0. Okay. And here this x and y is variable, and this variable x and y, we are getting all those points, that is the black curve here representing black curve. We will get all those x and y which are of distance r from the point h. X and y are variable here in this. So this is the equation of the curve, equation of the circle, equation of a. Now one can generalize this equation by little bit by this. So here if I write, if I use the formula for the square, then what will happen? X minus 8 square plus y minus k whole square equals to r square, right? X square minus 2hx plus h square plus y square minus 2ky plus k square is equals to r square. Fine. If I rearrange the terms, then we can write like this: x square plus y square minus 2hx minus 2ky plus h square plus k square minus r square. We will denote some constant here. So in general, write an equation of a circle by this equation 2. Right? Now, this h and k are in which coordinate that that will decide the sign of this term. Here it is minus, but if I put h equals to minus some h1, then it will term like plus 2 h1x, like that. We can change the sign depending upon the sign of the coefficient. We can say that the center of the circle is in which quadrant, right? So here we can see the two representation of the circle, equation of a circle. Here is the one representation, and here is the another representation of the equation of the circle. Now, what if r equals to 0? R greater than 0 is fine. What if r equals to 0? Then what we will get? We will get x minus h whole square plus y minus k whole square is equal to 0. Now, this is positive. This is strictly greater than 0. So, sum of two positive number equals to 0. That is only possible when both are equal to 0. So, this implies x equals to h, y equals to k. That means we are getting only a fixed point. So, whenever r equals to 0, then the circle is like nothing but a fixed point. The fixed point represents a circle of radius 0. Okay, fine. So thus we can get the equation of a circle, which is centered at h and k. Now, if note that if h, so okay, before that come to the geometrical perspective. So this is suppose this is our xy plane. Now circle is like the center will be like this, maybe h and k, and the radius of the circle suppose is less than this distance. Maybe this is some distance r1. Okay, and suppose r is less than r1, then obviously the circle will be like, but the distance of this r is much less than r1, as we have assumed here. Okay, now I can shift this. We can now according to our choice of r or anything, we can represent this circle different way. Like we can have a circle like this also. You can see the center is not changed, but in this case the r is the r is now bigger than the r1. R1. So this is the one case. Another case, it may happen that this HK point shifted to the origin. In that case, we will get HK here. It is 0, comma 0, and we will get a circle like right. Now come to some questions. You can understand much better by that. So question number one is How? What if I shift the H and K, which is the center of the circle, to the origin? Then what is the equation of the circle? So just simply say here that if I put H equal to 0 and K equal to 0 in this equation itself, then only we will get an equation, and also from here we will get the from both the cases I will get some equation. If I put H equal to 0 and K equal to 0, right? So I will not come to this point. I will apply the H equals to 0, K equal to 0 here, because in this case the C involved H and K, and if I someone don't know what is the value of H and K was included there, so in that case that will be difficult to understand what is the value of C. So better to include this H and K equal to 0 in this equation. It will be easy to handle. So first question is not question, it will be the intuition. If H comma K, this is equals to 0 comma 0, then equation of the circle will be x square plus y square, which is equals to r square. Okay. Now the r represents the radius of the circle. Now if radius is unit, if radius is unit, that is r equals to 1, then the equation will be, then will be x square plus y square is equals to 1, correct? And this is called a circle of radius 1, center at origin. Okay, so this is a very much important important circle, and is after whenever you will in the future you will get encountered with this kind of circles many times, specifically about this kind of circle, because usually the study of a circle of center arbitrary point is difficult. So which we naturally we do like we shift the circle to the center, the other case when origin at the center, and we study the whole circle and go to the go to our case and get some idea about our case to this case. So go to some arbitrary case. Equation of a circle with center minus 3,2, so radius 4. Okay, so clearly you can see from this equation they have given the value of h, k, and r, which are fixed real numbers. So in this case here, what are the h? What is h? Here h equals to minus 3. Here k equals to 2 and r equals to 4, right? Then if I put these values in the equation here, what I will get? You will get x plus 3 whole square, y minus 2 whole square is equal to 4 square. So this will give us x plus 3 whole square plus y minus 2 whole square equal to 16. Now if I further proceed this equation in this form, then how what we can get? So let us just write little bit, then we can understand what will be the answer. X square plus y square plus 6x minus 4y plus 9 plus 4 minus 6. So this will also imply as x square plus y square plus 6x minus 4y minus 3 is equals to 0. So yeah, you obtain this equation, this in this form. And here you can see that constant we have replaced by the c is x square plus k square minus r square. So here you can see that how we can obtain this thing. So from here it is difficult to get what is the radius, but yeah, you can find like this here from here. Like here you can see 2hx is 6x. So if I from here I can understand that h will be plus minus 3. Here you can clearly see that there will be minus and k is plus 2. If I put this and if I apply the formula, then we can obviously get the what will be the value of r from the using the constant. Well, from here also you can find the radius of the circle and all these things. Okay. So the third question is find the center and radius of the circle x square plus y square plus 8x minus 10 plus 10y minus 8 equals to 0. So simply we already have deduced the formula here. So we are just rewrite it here, right? So rewriting it, what I will get x square plus y square minus 2hx minus 2ky plus h square plus k square minus r square equals to 0. Fine. So from here, comparing, we get comparing, we get h equals to minus 4, k equals to minus 5. Why this is? You can clearly see this from here because here minus 2k equals to 10. So obviously k equals to minus 5. And similarly, h equals to minus 4. Okay. Now, what about this? So from here we know about h and k, so you need to find r. So r will be r square equals to nothing but h square plus k square minus r square is equals to 8. So this implies minus 8. This implies 16 plus 25 plus 8 is equals to r square. So this will give us 24 plus 25 is equals to 49. Okay, 49 r square. So this will give us r equals to 7. Now one can ask that r square equals to 49, then r equals to plus minus 7. Because usually we know whenever we take a square root, then in the front we must put some plus minus sign. But here you just understand that I have written that the r should be greater than or equal to 0. Here, the r should be greater than or equal to 0. So we will not consider the negative case. So that's why we are writing r equals to 7. So yeah, the radius of the circle will be 7. So what is the center? Let's run the problem. So the center is minus 4 minus 5 and radius is 7. Okay. Now, very good example. Find the equation of a circle center at 2, comma 2 and passes through 4, comma 5. So what is this saying? That we need to find the equation of a circle which has a center at the point 2, comma 2 and which passes to the point 4, comma 5. So here clearly they have given that h equals to 2, h equals to k equals to 2. So h and k both are 2. So the equation will be of the form x minus 2 whole square plus y minus 2 whole square is equals to r square, right? Now we don't know about r square, so we can't put directly the value of r square here. But indirectly, we can find the value of c. How? So they have given another extra case, that is the point 4, comma 5 lies on the circle. Okay, so the point 4, comma 5 lies on the circle. So we can put this 4, comma 5 on this equation. So we can put x equals to 4 and y equals to 5. So putting x equals to 4 and y equals to 5, you obtain 4 minus 2 whole square, 5 minus 2 whole square is equals to r square, 4 plus 9 is equals to r square. This will give us r equals to 2 to what 30. So we just need here r square, so we don't need about other square root term. So we can directly write at equals to 13. So the equation of the circle will be x minus 2 whole square, y minus 2 whole square is equals to 13. This will be the equation of the circle. And the next question is, find the equation of a circle which passes through the points 2, comma minus 2 and 3, comma 4 centered on the line x plus y equals to 2. Okay, so here They didn't put any condition on H and K and R, but they have given some points from where we can find the equation. So let's try to find the equation. So equation of the circle will be of the form like minus H whole square plus y minus k whole square. This is equal to r square. So this is the equation of the circle, suppose, and this circle passes through the point 2 comma minus 2 and 3 comma 4. So you can put x equals to 2 and minus 2 and also you can put x equals to 3 comma 4 in this. If I put what I will get, then we get in equations which are of the form like this: 2 minus h whole square minus 2 minus k whole square, which is equals to r square. And this is nothing but simply give us the equation of the form 2 minus h whole square, 2 plus k whole square. This is equal to r square. And the second equation will be of the form minus h whole square plus 4 minus k whole square. This is equals to r square. Okay. This is the equation number 1, and this is the equation number 2. We obtain two equations. From here, we can find an equation of h and k. How? So from 1 and 1 and 2, we obtain 2 minus 8. Then whole square. This is equal to 3 minus 8 whole square, 4 minus 10 whole square. Then, minus 4h plus 8 square plus 4 plus 4k square. Here we will get 9 minus 6h plus 8 square plus 16 minus 8k plus k. So from the both sides, h square and k square goes out. And if I rearrange all the terms, what I will get? We will get 2h plus 4k. This is equals to um, 7. I hope I am correct. Okay. So 2h plus 4k equals to 17. Okay. If I put 6h is there, 6h 2h, 4k, and for 8, 16 minus 8, 8. Also, from the given condition, h plus k, this should be equal to 2. Why? Because they have put in on condition that the center on the line this. The center lies on the line this. So center is the point h comma k. So h comma k lies on the point on the curve y equals to 2. So this will satisfy the equation h plus k equals to 2. Fine. So we obtain two equations. One is this one, another is this one. Now, this is a two solution and two unknown term is there. So we can clearly solve these two equations. How we can solve? So 2h plus 4k is equals to 17. And if I multiply this equation by 2, then we get 2h plus 2k is equals to 4. Subtracting, we get equation like 2k equals to 13, which implies 13 by 2. Okay. Similarly, we will get an equation for 8. Okay, maybe in some mistake or not, I don't know. Let's see once. Okay, so 4 minus 4h bracket square, 4 plus 4k plus k square, fine. 9 minus 8k, 18 will 4k. Okay. I have done some mistake here. This is not 4. This is 8 plus 12. It will be 12. It will be 12. Okay, here we will get 10k and k equals to 13 divided by 10, which will give us 1.3. Now, what about the h? H is 2 minus 1 by 1.3. So, this implies h equals to 2 minus 1.3. So, this will give us 0.7. Fine. So, we obtain h and k. So, what we need more? We need r square. For that, we can put the value of 1.3 and k is equals to 1.3 and k equals to 0.7 in this equation itself, and we can get a value of r. So I am not calculating that part. You can calculate easily that r square, and we will get the equation of the circle. Fine. So the equation of the circle will be of the form like this: whole square plus y minus 1.3 whole square. This is equals to 12.5. Is equal to 12.5. This is the equation of the circle. Now, one last question. That's the point. 3.5 lies inside or on the circle x square plus y square equals to 25. So here you can see we have from observing the equation of the circle, we can clearly see the center of the circle is at the point origin, and radius of the circle will be r square, which is equal to 5 square. So r will be equal to 5. So if I draw the circle, we obtain this. center is the origin, and radius is 5. So we will get some circle of the form like this. Here, obviously, this length will be 5. This length will be 5. This length will be 5. And this length will be 5. Because this is given here because this is 5 square. So the radius will be 5. Fine. Now they have given 1 point that minus 2.5 and 3.5. So minus 2.5 and 3.5 looks like this is the which quadrant? Second quadrant, right? Okay. Yeah, X is negative, Y is positive. So this will be second quadrant. So this second quadrant. So what we need to find the case that this point lies inside the circle, that is here, or outside circle like here or here, and on the circle. So how can I find this point lies inside, outside, or on the circle or not? Or where? So for that, we can do what? We can do, we can find the distance from the point this, from the origin, and we can check that the distance is less than 5, equal to 5, or greater than 5 or not. So that is the idea. So how can I do it? So the distance from the circle, from the center origin, will be 0 for the square minus 0 minus 3.5 whole square root. Fine. So now if I do the calculation, what I will get? Here we will get 6.25, and here we will get 12. Okay. We get 18.5, right? So this will equals to give some 4.30 something something will be there, and which is obviously less than 5. So this is one way. Now one can think of like that. If I don't know about this thing, this equation, we don't know about this equation, that is square root of 18.5 is 4.30. So you don't need to. You don't need to square root. So you can check that this addition is less than 25 or not. So this inequality implies that this is square must be less than this square. So this square will be 25. So you can just check that this sum, you can find the sum from here multiplying these things, and this sum is less than 25 on. If it is less than 25, then you can say that this is inside the circle. If it is equals to 25, then you can say that is the point lies on the circle. And if it is greater than 25, then you can say the point lies outside the circle. So thus you can solve the equation, or if you're using the equation circle, you can find the location of the point. So this is all about circle. We can discuss some few more questions related to JEE later on. So before that, we will go to our next section, which is our parabola. We will go to this case. So here you can see that when you can get a parabola, when the angle between the convex section and the uh, plane will be like this. So yeah, from there you can up to the parabola. So explicitly we will study the parabola, how, what is the definition of the parabola, and how we can study this. So the topic is parabola. Okay. So parabola is, what is parabola? Geometrically, let's understand the first. So suppose you have one point here. It is arbitrary point. I am not saying about any generalized case. It is arbitrary point here. And you have a straight line here. This is the minimum requirement for getting a parabola. You need a straight line and you need a point. Now, we need to find all those points which are equidistant from this straight line and the fixed point. So if I think about this point, so one point will be like here, right? After that, this point will be like this. Next, this point will be like this. Next, this point will be like this. So here it will be like a straight line, and here it will be like this. So if you join these things, so you may get one curve like this. We roughly have saying these things, you may get some much more accurate curve. Yeah, just roughly you can see that all the points on this green line are equidistant from this point from the straight line. So this is called, and this geometrical figure is called a parabola. So by definition, what we can say is the set of all those points which are equidistant from a fixed line and a fixed point, which is not the which is not the line. What is that mean? That we have considered, we have one hypothesis that this point, this must be not lie on this black line. Okay, so that this point which we are this point which is not lying in the on the line. It may happen that the line that this point lies in the right of the line or left of the line, but that will not lie on the line. Okay, because suppose we can find in the case that if this is a straight line and the point lies on, that is a point, that is this point lies on the line. Now we need to find all those points which are equidistant from the line and the point. Now you can check that from this point or any point which are equidistant from here will be the straight line passing through this point. How? Just think. First of all, we get this point, red one, right? Because this is equidistant from the origin, from the green point also, and from the straight line. It will both the distance will be zero. Now, if we consider about this point, this point is the from the green line. We have from the green point. It has some distance. So the distance from this new red line, new red point, that is the okay, it's a different color. This yellow point. The distance of this yellow point from this green point and the distance of this yellow point from the straight line is same because we are finding whenever we are finding some distance from a straight line, we are usually what we do? We do the distance of this point and which is perpendicular to the straight line, right? So if I draw the perpendicular, you can clearly see that this is the distance from the green point and this is the distance from the straight line. This is equidistant. And similarly, if we consider this point, this point, this point, this point, this will always give the distance from the fixed point and distance from the straight line are same and that will in the same direction. So ultimately we will get a straight line in this. It is perpendicular to the considered line, considered black line. That's why we don't consider the point, green point should lie on the line. We must consider that the fixed point, that is a green point, is not on the line. It is either left or right, and depending upon the point is left or right, we will get different equation for the parabola. Okay. So if I consider this case, this is obviously a parabola. So in this case, this point is called a focus. This point is called a focus, and this point, this line is called directrix. This point is called, this line is called the directrix. Okay. Now, if I join the line this and if I this focus with the line, and we will get a perpendicular line from here, right? So this will intersect this parabola, and obviously this will be the midpoint. The distance from this red dot from this line and from this focus will be same. So the distance from this and the distance from this will be equal. Why equal? Because it is the definition of the parabola. We are finding all those connections which are equidistant from the fixed point and the line. So we have just joined that with that line. So this green point, that is a new red dot, must intersect or bisect that line segment, right? So this is called this line is passing through the line is called the axis. This is called the axis, and the point which bisects this line is called the vertex. So this all we need to know. We need to worry about this case of parabola. So what we need? We need the axis, we need the focus, we need the vertex, and we need the directrix. Now just understand one fact that from the vertex, the distance of the focus and distance of the directrix will be same due to the definition of the parabola. Now, in general, it may happen that the directives can be arbitrary and the focus is at the any point on R2 plane, and we can draw a parabola depending upon the directrix and the focus. But those are not that a point of worry for us. Usually, that is not that much used, or that is the beyond the scope of this low level classes. So we just need to bound in the case where the axis is parallel to the x-axis, or you can say the axis is the x-axis or y-axis. Okay, so in this case we will find the equation of the parabola for cases where the axis is either the x-axis or the axis will be either the y-axis. So depending upon that, we can have few cases. So if the axis is x-axis, then what happens? This is our x-axis, okay? And suppose that we have a point. So axis is like then focus will be on the x-axis. So this will be the point, and maybe straight line can be like this, or it may happen that the straight line is like this point here. Straight line is like this. Two cases may arise, right? Whatever you decide that the fixed point will be not on the line. So two cases may arise, either it is on the left or either it is on the right. Now, if it is a left, then we will get an parabola of this form like this. Yeah, bisect, right? And in this case, we will get an equation of the form. We will get a curve of the form. Okay. So this is the case when the axis is the x-axis. And if the case is like the axis is y-axis, then what we will get? I am not going to another page. It will be finished here. Yeah. Suppose there was y-axis and this is our y-axis. So obviously the point of fixed point will be on the curve. Here this may the case, and here this may the case. So depending upon the fixed point and the directives, we can say in this case the curve will be like this, and this there the curve will be like this. Now one may ask that okay, yeah. Now one may ask that that's the equation of this all these parabolas will be equal or not. So that we will discuss in the next class. So just recall one fact that question of the four cases will be different, completely different, not completely, but the pattern will be similar, but the sign, the coefficient sign of the coefficient or the direction or many things will be different. So those things will come in the next class. But yeah, we can before that, before coming to that question, we will understand how we can get a question of the parabola. So you may try yourself, but like before the next lecture, that you can find the question of trajectory of all the points. You can find one point x comma y here. You can fix the point a comma 0 here. You can fix some points here, and you can just try to find the distance from here and distance from here. Now this exercise is moving, but this is fixed and line is fixed. So the distance you will give some equation because finding distance from here and distance from here to here. And if you equate that to distances, you will get some equation in terms of x and y. And from there, you can construct an equation for parabola, and you can try this same concept for four different cases. Then you can at least you should try these kind of things. In the next lecture, I will discuss how we can get the equation of the different different case of parabola. But we will restrict to some particular cases. We will not go to some generalized version of this equation of the parabola. So today we will end at this point. We will start from here for the next class.